Quantum theory describes the fundamentals of nature from the smallest building blocks to the vast universe as a whole. The Netherlands is a pioneer in quantum science. Through its innovative ecosystem and high-tech industry, it has made significant leaps in quantum theory. In 1935, Einstein asked a profound question about our understanding of nature. Are objects only influenced by their nearby environment? Or could, as predicted by quantum theory, looking at one object sometimes instantaneously affect another faraway object? Einstein did not believe in quantum theory's prediction, famously calling it spooky action. Exactly 80 years later, a team of scientists led by Professor Ronald Hansen from TU Delft finally performed what is seen as the ultimate test against Einstein's worldview, the loophole-free Bell test. The scientists found that two electrons, separated 1.3 kilometers from each other on the Delft University campus, can indeed have an invisible and instantaneous connection. The spooky action is real. When it comes to cutting-edge quantum theory, Delft is where it's at. In 2013, QuTech was announced by the government as a collaboration between the TU Delft and TNO with the ambition to move from quantum science to quantum engineering.
At QuTech we're building a quantum computer and a large-scale quantum internet.
Quantum information is an exciting and fast-moving field of research.
In 2014, QuTech was selected as one of the 4 national icons. The building blocks for a quantum computer and quantum internet are jointly being developed by public and private partners such as Intel and Microsoft. The highly reputed researchers and professors are joined in a common goal: to answer some of the most fundamental mysteries of quantum theory.
So how can a quantum computer actually be built? In fact, how is a single qubit realized? And how can we ever put together many qubits in a large-scale machine?
What is quantum teleportation?
What is quantum information? What is a quantum bit, a qubit, and how does it differ from a classical bit?
In my lab, we use electron spins in silicon quantum dots to realize quantum bits. Quantum states are extremely fragile. The art of quantum computing consists in, on the one hand, isolating quantum bits from the rest of the world, and at the same time breaking that isolation to perform operations on them. Making any type of quantum bit is extremely challenging. It requires ultra-clean materials and very precise nanofabrication methods. Besides qubits in silicon, at QuTech we also pursue other approaches, like Majorana fermions, superconductor qubits, and nitrogen vacancy centers in diamond.
And Majorana fermions allow for so-called topological quantum computation. So in 2012, here at the TU Delft, we were actually the first to measure signatures of Majorana fermions. Now for topological quantum computing, you need to braid them around each other in order to do a quantum operation. And for this project, we worked together with Microsoft.
Superconducting qubits are a very promising approach for quantum computation. We're hoping to scale to 49 qubits in 5 years using a surface code architecture.
The first step will be to build a quantum network connecting several cities here in the Netherlands in the next 5 years. For a quantum internet, we need qubits that can travel long distances. For this we will use optical communication, connecting network nodes that are essentially small quantum computers, comprised of NV centers in diamond.
To make a quantum network from real devices, we need to correct errors and distribute entanglement effectively. Interestingly, however, quantum information theory also tells us a lot about other areas of physics.
Apart from doing groundbreaking research in the field of quantum technology, QuTech also has a QuTech Academy, where master's courses are offered in cutting-edge research of quantum technology at the heart of where the action is happening.
At QuTech Academy, you will learn about how quantum computation can be implemented. You will learn about the many approaches to quantum computing and how they compare.
In QuTech Academy, students from physics, math, computer science and engineering can learn about quantum technologies.
QuTech Academy provides the education that you need to solve many of the challenges that we have in quantum technologies.
Here at QuTech Academy, you will learn how to realize the hardware that is needed to build a true quantum internet.
Master students are extremely valuable to solve all these problems in the lab.
We need very intelligent and passionate master students to help accelerate the efforts here in the lab.